Hi guys, my name is Mahesh and today I'm going to show you how to do a t-test in Excel. The t-test is used to determine if two sets of measurements are statistically different. Basically, there are two kinds of t-test which are paired and unpaired t-tests. Here I have a problem based on a paired t-test. The paired t-test involves comparing data obtained on the same set of samples by two different methods, person or labs and so on. So the problem here has two different um, methods, enzyme method and calorimetry method, which are used to determine the level of cholesterol in serum. One important characteristic of a pair t-test is that the number of data points are always the same because we are using the same set of samples. But before doing a pair t-test, it is useful to check if two methods have equivalent variance or precision. So f-test is required, which simply checks if there is a statistical difference in precision between two methods. It is simply calculated as the ratio of the squares of the standard deviation. So so I'm gonna calculate the standard deviation of the set 1, which I suppose it's enzyme method. So I calculate the standard deviation of the enzyme method, which I assumed as S1, and similarly I calculate the standard deviation of the second method, which is calorimetry method. Here I get the S1 107.23, whereas the S2 is 111.92. But on F test, if you wanna put the S1 on the numerator, it has to be greater than the S2. So in this case, S1 is less than S2, then we cannot do an F test. So we have to change the S1 and S2. So I have to take this one as S1 and this one as S2. So I'm simply gonna change the S1 as the calorimetry method. V and this the V, which is degree of freedom, is simply 9, calculated as the number of samples minus 1. So we calculate the F value, which is the, like I told earlier, is the ratio of squares of the standard deviation. So equals to S1 squared divided by the S2 squared. I'll get the value 1.08. Now we're gonna, so you can check in the textbook for the F value at 95% confidence level. I get the F table value from the textbook as at 95% confidence level as 3.18. Alright, since the F calculated is less than F table, we can say that the two different methods, in these two methods, there is no significant uh, difference in the precision. So we can go ahead and do a t-test. For the t-test, go to data and then data analysis, scroll down. Oh, okay, so you select the t-test, pair two samples for means, and the in the input in the variable one range, you select the one of these method. In this case is the enzyme method, and then for the variable 2 you select the calorimetry method, and do not change the alpha. That's for the confidence level. If you want to do at the 95% confidence level, you put 0.05. If you want to do 99, then you put 0.01. If you want to do 90, I mean 90% confidence level, you put 0.1. For the output range, you select any of the cell. So I'm in this case I'm gonna select this one right here and hit OK. So I get the so in this t-test you see a lot of different stuff like mean, variance. We don't need everything. Like degree of freedom we already calculated as 9, you can see right here, and we are really concerned about the t-stats, which here is 1.86, and then we're gonna compare this with the t-table value. This is t-stats is also same as the t-calculated value. So t-calculated is 1.86. Now we're gonna get the t-table from the from at 95% confidence level, which I have in the C2. So we have 9 degree of freedom. So we look at the 95% confidence level, which is right here. 9 is 2.26. So it's 2.26. So as you can see, t calculated is less than t table. So that means there is no significant difference in these two methods. They provide the same result. Alright, thank you for listening.